So today we're going to talk about something slightly different, but not very different. So it's recommendation systems. I mean, everybody here has probably seen recommendation systems somewhere, right? Today we're mainly going to talk about the recommendation system itself, and if we have time, we'll talk a little bit about clustering. And we'll also do a small example with recommendation systems. Okay, so what is the recommendation problem? Let's say you have some client, you have a grocery shop, okay, and you have a client coming in and they want to buy groceries, and you would like to recommend them some items to buy, okay? Maybe some things that are hard to find because they are far away in the supermarket, or they don't have time to go through it. So you say, well, I know this person, I know he likes fish, so here is some fish, okay? I know on Friday they eat fish. So typically, if you're a website and you want to have some kind of recommendation system, you just have some observations about the customer. This can be pretty complicated. Lots of websites these days use services from tracking services, which kind of use basically cookies and single pixel images to track you around the web, so they can guess more or less stuff that you like. And then when you go to a particular website, then you will see recommendations for things, or you see the website adapt to things you have seen before on the web, and not necessarily on a specific website. But today we're going to talk about the case where you're mainly looking at just one website, and this one website has data about you that you specifically agreed to give to this website. So we don't care about this external stuff. And then the website will present you a choice, okay? Let's say bananas, fine. And then you choose something. The choice can be anything. It can be choose to buy one of these things here, or all of them, or nothing. You know, go away, okay? And then you obtain some reward. Now, typically, if you look at this as a decision problem from the point of view of the website, what you would like to do is maximize some utility function that relates to this reward. So typically, if the reward is the amount of money that somebody pays to buy your products, then you would typically maximize the sum of these rewards, so the sum of money you make over time. Okay? Yeah. Now, there are actually two problems in recommendation systems. The first problem is, how do you model what people like, or how can you predict what people will like? Okay, this is purely statistical inference problem. We have looked at it a little bit for some classification problems and things like that, but for recommendation systems it's a bit more complicated because you have things, they have properties, you have people, they have also properties, and have relations within each other, and you have to somehow guess from data about many different people and many different products what products somebody would like. And then there is the recommendation problem, which is actually another problem altogether. Even if you know exactly what items some person would like, you still have to decide what to recommend, okay? And then they might not buy what you recommend, even if it's very high on the list of possible recommendations. If you have 1 million products to recommend, and if you think that 1,000 of them are possible things that the user might like very highly, then it's still a difficult problem to say which one I can recommend. I can't say here are 1,000 things, choose one. So it has to be a small list, small enough that somebody can choose from. Okay. Okay. So typically, we have some data about what users like. Okay. And one example of this data that you've all seen before probably is movie recommendations. So typically, if you are a member of some movie website like IMDb or Netflix or Movie Lens, then movies that you like, you can put number of stars, so 1, 2, 3, 4, or 5 stars. Okay. And for the prediction part, what would you like to do is, if you have a new movie comes out, you would like to somehow guess what rating somebody would give to that movie, even if they have not watched that movie. Okay? So here, there are some numbers. You can try and guess what those numbers mean and where they come from, right? So here, for example, there is a number that looks somehow like it's between the average of this one and that one, maybe. We don't know. And this one seems to be somewhere in between those numbers. So the way this works, I will explain it later, is that for every one of these other movies, you calculate some kind of similarity score. Okay? And then you calculate the weighted average between this one movie and all the other movies. Basically. That's very simple. So here you see the similarity score, it's 0.86, so this movie is very similar to this one apparently, and also very similar to this one, and has a minus factor for this one. So it seems to be very dissimilar with respect to these movies here. You can do the same thing for people, so you can try and fill in a row of this matrix by averaging the values of different people, so you can predict what each person would give a score for a specific movie. Okay? The simplest way to do that is basically to just average all the scores of the movie, right? And then just have fill average for everybody's score. But of course, every person is different, so you would like this to be different for every person. So you have to have also the similarity between people and movies somehow. Okay? So this is not an obvious way to solve this, right? But we can go step by step and together discover some solutions. Okay? So this is how we're going to do it today. Okay. Now the second thing is what to recommend, right? Now typically, the problem with recommendations is that there are many items. Let's say moves. So even if I just recommend, if let's say I make a list here, right, of filling your scores. And for the things that you have not watched, I put, let's say, estimates. So let's say I want to put the top 100 movies according to my estimates. Okay. Now, you can only fit 100 movies here, so you can only fit 4. Okay. Now, what happens is this. Let's say that you don't like any of these 10 movies I showed you. What happens then? So you go to the website, I give you 10 movies to choose from. You don't like any of them, you go to some other website or you search the website, right? Okay, let's say tomorrow you come again to the website. What should happen then? Let's say your scores have not changed for this movie, so they are still top 10. Yeah? Yeah, so somehow you should change your score now based on the fact that you didn't click on the movies, right? Yeah. Even though you didn't actually rate any new movies maybe. So it's just the fact that you clicked, right? Yeah. So you have to also predict the behavior somehow of the people based on their actual actions. Okay? This creates other problems. If you look back in the past and you see what movies people rated and what movies people watched, you don't see what would have happened, let's say last year when a specific movie came out, if I recommended it to you, maybe you could have clicked on it and bought it. But if I didn't recommend it to you, you don't know what you would have done. Okay? So say this year, same day, there was, I don't know, Jurassic Park 500, okay? And I said, yeah, watch this movie, and you didn't click on it. But the same day, there was also coming, I don't know, Spider-Man 5, and I didn't recommend to you, but if I had done that, then you would have clicked. But there's no way to model that, yeah? So, at least today we will not talk about that. But these are main problems with this interactive decision making. And can you give an example of, do you think that the banking example actually relates to that as well? A little bit? It's not really strictly a recommendation, but it's actually making decisions, right? So what happens is that, let's say that a customer comes, you decide to give them a loan or not, right? If you decide to give them a loan, that's nice, because then you can see whether or not they return, so you have more data. Yeah? If you don't give them a loan, then you don't know if they will going to repay it, right? So if you, for example, somehow you classify it such that it gives a very bad score to a specific category of people and they never get a loan, then you never improve their score. Okay? So this kind of feedback effect is very difficult to get rid of, and it's one of the main reasons why when we do experiment design for clinical trials, for example, we use some randomization. So even if you think that probably this person will not benefit from watching this movie, then you still might, with some probability, recommend a movie that they want. And also with the loans, sometimes, even though you think that some person might be credit worthy, you might decline the loan randomly, and vice versa. So randomness is important. Yes?
I was just thinking you were talking about this feedback.
Yeah.
They show you 10 movies and you don't like any of them, then that's some sort of information.
Yeah.
But I think you have to take that be very careful about that. Because sometimes I go in and I see, what movie do I want to see tomorrow? And then it's like, okay, these 10 movies, maybe some of them, and then I go tomorrow, I was like, where did they go? They're all gone.
Yeah.
It's not that I didn't want to watch them, it's just I didn't watch them right now.
Right, yeah.
And I have the same problem most of the time with Facebook.
Yeah.
I go through it, and sometimes I see this link to a newspaper article or something. I'm like, I'd like to read this. And suddenly it cries or something, and I put the phone in my pocket. And when I come back, it's disappeared, and I can't find it back.
Yeah. So there is feedback, right? But it's hard to see what the feedback is because it's indirect. So it's not like you say Facebook or Netflix, I don't like these movies. It's just that you didn't click on it, and that can mean anything. Yeah. It does mean that you don't want to watch them right now. Okay. So that's something.
Or the count for the sound.
Yeah. So this is definitely a problem, and this is why today we're going to focus a lot on what is called latent variable models. I'm just going to start with it. So you can say that whether or not you like a movie is a latent variable, or whether or not you like to watch it at a specific time. And you don't observe that, you just observe some other variable that depends on it. And then you have to infer whether or not you like the movie or you like to watch it. And then from this inference, you have to decide whether or not to recommend it again or not. But there is no easy answer to this. Otherwise, they would have solved it. Okay. So how do we, let's go to the easy problem, okay? The easy problem is the prediction problem. So there are two ways to do it. If you have a lot of information about the different items, and you know what people like, then you just match items to people. So it's action movie starring, I don't know, XYZ, and then I know that you watch many movies, action movies with XYZ, so if there's a new movie coming out, I will recommend to you, just because you like this particular type of movie, okay? But this has a strange effect that, let's say you go to Amazon and you buy an air conditioning, then tomorrow Amazon will also tell you, well, here's another air conditioner. You don't want it, but you already bought one, okay? A more promising idea is to use what's called collaborative filtering. So here we use this matrix that we saw before. The idea is that people that are similar to each other, they have similar tastes. Okay? So if I know that you three on one side are similar and the other three are also similar, then I could substitute one's ratings for the other's ratings, let's say. So even if you have not always exactly the same movies, you have some overlap, and for the movies with the overlap, you have the same ratings, so I can guess that the other ones you might also have the same. So that's the idea. Okay, so we'll do this now. Okay, we'll actually do a simple program. Let me find the program. So we're going to use very, very simple algorithms for this. Just open this thingy on my computer. Yeah.
Like if three people are similar taste and two other people are similar taste, and I come in, you don't know which of the two groups I would fit into.
Yeah, that's fine.
So then you just use some random things and sort of try to see what group I fit in.
And you might choose mainstream things.
Yeah. I mean, talking now about specifically about Netflix, you would have, let's go back there. You see, I have three lines there, right? And one is stuff, like the generic recommendation, and then it's like category-based recommendation, so like what we mentioned before, like type-based recommendation, and the other is so you watch TV movies and TV shows that are irreverent, and maybe they're popular right now, and then you would be like, you have these things as well, okay? But as long as you can be placed into a cluster, then it will be fine. If you don't know which cluster you belong to, which you never do, exactly, then you just assign the probability of belonging to a specific cluster. So if most people just like popular, like the very popular blockbusters, then you assume that they're there. But 10% of the people who like, I don't know, 50s movies, black and white, I don't know. So you might get some of those too. So normally, again, this is part of the recommendation problem. So say, if you have 10 movies to show and you don't know anything about the person, then you should show the movies that will give you the maximum amount of information about what this person is. Yeah, that's what you should show. And then you can very quickly get, yes?
I'm not necessarily agree.
Why?
Because, from a company perspective, like Netflix, you should show, since if you don't know anything, you probably try to steer their taste, so you show more Netflix shows, or more so you get integrated in the company system, and not necessarily the other stuff, so the company can get more revenue.
That's a great point. Yeah. I mean, as a heuristic, so what you say is exactly right. So if you define this as a utility function that you want to maximize, then and you know that you have some shows that you produce yourself, you get more revenue basically by someone actually watching the show. So you have to have two things. You have to have a predictive model saying that people that watch the show will keep on watching the show for some time, so I will make more money. And then what else? You have to have automation program that tells you, well, when I do get this information about what people are watching, then, well, I have to talk about this much later though. So, one of the things is that if you just formalize an optimization problem with sequential decisions, then naturally what you get is some kind of attempt to maximize information what the user likes, but not directly, it's kind of indirectly. So what people do use, because it's a complicated automation problem, what people do use in practice is they use some heuristics where they say, okay, I have some need to understand what the person likes inherently. So they use a heuristic by trying to myopically maximize information gain about a specific customer. And at the same time, they won't have some simple heuristic for maximizing revenue. Again, it's never going to be a very complicated algorithm because there are thousands of users at the same time and you cannot run anything super complicated. But if you put all the variables in automation problem, in theory you get something like what you say. So I guess in practice what Netflix is doing is saying, okay, just put more often these kind of shows because we know we want more revenue. We'll get more revenue from these shows, but not necessarily something else. And there is another thing to consider, right? So if you look at people's behavior, right? Say, I want to watch my 50s movies, and you are keep bugging me about these Netflix shows that I don't care about. Yeah, then I'll just quit Netflix and go somewhere else. Right? So you also have the retention of customers and things like that. So if you had a really sophisticated customer model, then you would put all these factors in there. So there are different types of customers, and there's a retention rate that is different for every type of customer depending on what you show them. So you don't necessarily want just to click this one movie, you care about the long-term retention rate, right? And honestly, I don't know if any company is doing that. From what I've seen with Spotify, they just do very simple stuff most of the time. and we will cover some of it in this course. I don't know what Netflix is doing. I know something about Amazon or Adobe, but none of them are doing something like where retention was. It would be really nice, but maybe for a smaller scale, I don't really know.
After my experience, the ones who makes decisions are the one who sees the numbers and we not need more revenue.
Yeah.
Therefore, we maximize the revenue, not retention. And since you get more money
Yeah.
faster, but it's not good in the long run. You don't maximize retention and yeah.
Yeah.
Seems to be greedy.
Yeah. It wasn't really good. So in the long run, it's not necessarily good. But I think those models come in a couple of years. We'll see.
We'll see. Okay, but now we'll do something much simpler, okay? Alright. Okay, if that's okay with you. I mean, we can also try something like that. Something. Okay, I think we are kind of ready. I will try and I already have the code done, but I will basically redo it just for fun. Okay. Okay. Let's do this now, I guess. Okay, good. And shall, fine. Okay. So one thing that we could do in order to get ratings for users and movies is to kind of take a look at how different users are in terms of the ratings, right? So if two people are very similar, then we can say that they are close, they have small distance because they have similar ratings, and then we can use the ratings of the closer person to get our ratings. Okay? So first of all, you have to define some kind of distance between people. Okay, so here is distance. But before we do the distance, let's say how we generate the data. Here it's basically kind of randomly generated. So everybody has a random rating about the movie. There is no structure in the model at all, and just generate a bunch of data. Okay? Now, we would like some way to compare two different people to see whether they are close or far away. And the simplest thing to do is to just look at the distance, let's say in this case, the L1 norm between the ratings of one person and the other. So X and Y here are basically, what is X? X are the ratings of one user and Y of another, okay? So do you think this is a useful distance? Do you think it's okay? Yes?
What will the distance be a person hasn't watched?
Yeah, that's a good point.
Film,
Yeah.
another has, or,
Yeah.
yeah.
So if somebody hasn't watched the film, we probably, if they have not watched the same film, we just probably want to ignore that, maybe, yeah, or discount it at least, yeah. So typically would say if X is 0, it's not 0.
It does give some information because someone similar would maybe watch similar films.
Okay, yeah. That's another thing. So we have to decide on where it is, okay? So first of all, we can add the distance, this thing to the distance, okay? If they're not 0. What if they are 0? Maybe if they're both 0, then we don't care, right? Because they didn't watch the movie, none of them watched it. But maybe if one of them has watched it and the other hasn't, would like to make them slightly dissimilar, add a little thing. Yeah, but we don't know, right? So we could do that as well. Okay, so let's do that as well.
I mean, if you want to really do this properly, you have to see, okay, this person hasn't watched this movie, but it has watched the same movie as somebody else who has also watched that movie, so we can use that to infer what they would have rated it as if they...
So you're talking about creating a network model from the users. That's okay. Bye. Okay, so we can add that too. That's not a problem. Okay. So let's say we add some factor. A small factor if they have watched one movie and the other one hasn't. Yeah, it's okay. But typically, what we see, because it makes things easier, is that we just ignore the movies where people haven't watched. Okay, but we are allowed to do anything we like. Yeah. Okay. So now we would like to return basically a vector that gives a similarity between users, right? And so we have a user here. We have some user u and the data of all the users, including this one. Okay. So basically we can loop for range and users. And then we can say similarity w is equal to is equal to exponential, for example, or any other decreasing function of the distance. Minus distance, let's see, data I and u, data u. Okay, fine. Some user index, yeah, let's make it clear. Okay, I'm using an index here because I want to avoid having the same user self-similar. We don't care about that. Okay, and then in the end we can say return similarity divided by similarity sum, just to make it sum to 1. It's not necessary, but it's nicer. Okay.
One more practice on
Similarity, where there? Yes. Okay. Great. Okay, that's simple enough, right? So now we can try and infer the ratings. It's not difficult again. How can we do it? Using the similarity. What is the problem now? The problem is that some users haven't watched the same movies, right? So we'd like to create similarity for a specific movie only for the people that have watched the movie, right? Yeah. So let's say these are inferred ratings. So let's say W is a vector of similarity. Get similarity. We have the data and the user. Fine. Now we would like to go through all. Oops, maybe this is here. Yeah. I'll go through all the movies, and we basically set W to 0 for the movies that are not 0, that are not watched by the user, right? So for I in range and users, okay, now we say, okay, I should do this here, I guess, because it depends on the movie, right? WI, okay, if data user and movie 0, right? Then this one is 0. Okay, there is a vectorized way to do it probably, but I always mess it up. Okay, and then you say, well, W divided equal by W sum, I guess. So now I have a similarity between all the users that have watched the same movies as I have. Actually here I only care about the movies I haven't watched, right? If data I and U and M is 0, right? The other ones I don't need to fill in. Yeah. Okay. So for the movies I haven't watched, I get a similarity for all the users, so I have to normalize it again to remove the users that haven't watched the movie. Yeah, does it look okay to you? So if somebody hasn't watched the movie, then I just set his weight to 0. And then I just divide by the sum of the weights. Okay. And now I just need to get a score, right? And so I just set the inferred ratings of my user and the movie to be basically the dot product, right? Between, I guess it's NP dot, or no, W dot, and with ratings, yeah, the original ratings, not the inferred ones because the ones already changed, data, and then, no, I don't remember what it was, so it has to be for that movie only. How do you do that? Well, I already did it, so here it is somewhere. Yeah, that's it. Data /m. Yeah, that's easier. Yeah, this is the syntax. Yeah. Okay. So now basically you have a method for inferring ratings for all the movies, right? Yeah. And then you can return inferred ratings. Okay. So that's the basic idea here, and it just relies on the data directly. It doesn't try to estimate anything complicated. Yeah. But then we have some problems with that. It kind of weighs, so two users will be very, if they have only, let's say we watch 100 movies, right? And we only differ in one by one. Yeah, so we are very similar. Okay, and then we only watch one movie each, and then we again differ in one by one, then the distance will be the same, right? In this metric. So do we do it by average? Again, we can play around with distance measures and stuff. But this is a very ad hoc way to do it somehow. But this is not bad, but it's still kind of ad hoc. So what people would like is, instead of looking at the ratings directly, to create some kind of compressed model of that represents what the movies are, and a compressed model that represents what people are, and together those two compressed models can give us ratings for movies for people. So you have a simple representation, let's say a simple vector that represents a movie and a vector that represents a person. Let's say you just take the inner product of these two and it gives you a rating. So if you had a way to do that, that would be very nice. Yeah? Much simpler than this. So you can define it as an optimization problem. And we'll do that after the break.